everyone, myself Shweta Jha and I am your instructor for the subject microprocessor and microcontroller. In this subject we have started unit 6, that is peripheral interfacing, and in this session we are going to see today the topic that is relay and opto-oscillator interfacing. Now let us start with the first, electromechanical relays. A relay is the electrically controllable switch which is widely used in industrial control, automobiles and appliances. It allows the isolation of the two separate sections of the system with the two different voltage sources. For example, 5-volt system can be isolated from the 120-volt system by placing a relay between them. And one such a relay is called as an electromechanical or electromagnetic relay, that is EMR. And these EMRs have the three components, that is the coil, spring and contacts. The digital 5 voltage on the left side can control a 12 volt motor on the other side without any physical contact between them. Okay, so this kind of structure is known as the relay. When the current flows through the coil, the magnetic field is created around the coil and the coil is energized, which causes the armature to be attracted to the coil, and the armature is act like switch and closes or opens the circuit, which when the coil is not energized, the spring pulls the armature to the normal and state of open or closed depending upon the condition. Now let us see the criteria that we need to consider while choosing the relay. There are different types of relays for different application. In choosing the relay, you have to consider the following criteria. First thing, the contacts can be normally open or normally closed, that is NO or NC. In the NC type, the contacts are closed when the coil is energized, and the NO types, the contacts are open when the coil is unenergized. There can be one or more contacts. For example, in SPST, that is the single pole single throw, SPST single pole double throw, and the DPDT, that is the double pole double throw relays. These are the different kind of relays that has one or more contacts. The voltage and the current needed to energize the coil, and the voltage can vary from the few volts to the 50 volts, while the current can be vary from few milliamperes to 20 milliamperes. And the relay has the minimum voltage and below which the coil cannot be energized, and this minimum voltage is known as the pull-in voltage. So you require to provide this minimum voltage to energize your coil. And the maximum DC or AC voltage current can be handled by the contacts, and this is the range of few volts to the hundreds of volt, while the current can be from a few amperes to 40 ampere and more depending upon the relay. And you have to notice that the difference between the voltage and current specification, the voltage or current needed for the energize the coil, and the fact that the one can use such a small amount of voltage or current on one side to handle the large amount of voltage and current on the other side, which makes the relays to be widely used in this industrial controls. And this is the basic single pole single throw, single pole double throw, and single pole double pole double throw switches, or you can say relay. So you have more contacts in this double pole double throw. Here two contacts, here one contact. So this way you can use this relay, and you have to interface this with the AVR controller. Now let us see the opto-isolator. In some application we can use the opto-isolator, that is also known as optocoupler, to isolate the two parts of the system. For example, driving a motor. A motor can be produce what called the back EMF, and the high voltage spike produced by the sudden change of the current, as the indicates the formula V is equals to L into di by dt. So there can be a sudden change in the current, and that cannot be handled by the relay. So instead of relay, you can use the opto isolator. In this situation, such as a printed circuit board design, we can reduce the effect of unwanted voltage spikes, that is called ground bounce, by using the deep coupling capacitors. In this system that have the inductors such as a motor, decoupling capacitor, or the diode will not do the job. So at that case you have to use the opto isolator. We can use this opto isolator, and it has a LED, that is the light emitting diode, as a transmitter and the photo sensor receiver, and that is separated by the gap. So here you have LED as a transmitter and the photo sensor as a receiver. And when the current flows through the diode, they transmit a signal light across the gap, and receiver produce the same signal with the phase but the different current and the amplitude depending upon the light which is formed on this sensor. Opto-isolators are widely used in the communication equipment such as the modems, and this device allows the computer to be connected to the telephone lines without the risk of damaging or the power surge. And the gap between the transmitter and receiver of the opto-isolator prevents the electrical current surge from the reaching to the system. So your system will be safe. Now, when you interface this opto-isolator, it comes in the small IC package of the 4 or more pins, and there are also packages that contains more than one opto-isolator. And when placing the opto-isolator between two circuits, we must use the two separate voltage source, one for each side. Unlike the relay, there is no drivers needed to place between the microcontroller and the digital output and the opto-isolator. So this is the basic structure. Here you have the two opto-isolator. First one here, this is the LED for the transmitting the light, and this is the sensor for the receiving the light, and depending upon that you can control. So this is the basic structure of the opto-isolator. Here two opto-isolators are used. So here we are ending our today's session. If you have any query, then you can contact me.